Hello and welcome to the second chapter about the drive monitor within the Flexi Designer. In the last tutorials about the encoders, I have explained where the various encoders are located in the FSD, how to connect them to the terminal of the drive monitor, and how to configure the different encoder groups individually. Now, in the second chapter of this tutorial series, we are going to take a closer look at the various function blocks in the mock logic. The chapter function blocks in the mock logic is divided according to the different function blocks in 6 parts. Speed cross-check, speed monitor, UI8 to Boolean converter, Boolean to UI8 converter, save stop, and at last, speed to laser scanner. The videos build on each other, so you can see how to combine the function blocks to get a typical mock logic in the end. Now let's start with the first tutorial about the function block speed cross-check. This function block generally compares speed values from 2 different signal sources. The checks made during this process are used to achieve a higher level of safety, in particular if non-safety encoders are used. Sometimes there are temporary or even continuous differences between 2 meshed values. This happens, for example, by slip, friction, or mechanical behavior. Therefore, the function block provides various parameters that can be used to compensate such differences. In this way, wrong switching can be prevented and the availability of the machine safeguarded. Let me also give you a short overview of the different in and outputs of this function block. At first, we have the inputs motion 1 and motion 2. Here the signals of the encoders are connected to. Therefore, the speed cross-check gets all the information provided by the encoders. Furthermore, there is the optional input inhibit error reaction. It can be used to prevent the error reaction in specific operational situations and reset the fault automatically. Another selectable input is the reset. With this input, it's possible to reset a fault condition using an external signal. If the last optional inputs enable limit 2 and enable limit 3 are used and a high signal is present, it is allowed to exceed the configured value for the relative speed difference of limit 1. About the outputs. The first output motion contains the resulting motion information, which is speed and position, plus the status information of the encoders. And the output monitoring status, which is normally high, goes low if the allowed relative speed difference is exceeded or an encoder error is detected. It goes high again when the error has been reset either by the input inhibit error reaction or the input reset. Now let's jump in the hardware configuration area of the Flexi Designer to consider this function block in more detail. As you can see, I have already selected a CPU 0 and a MOX 0 and connected an AB incremental and an SSI master encoder. In the next step, I switch to the mock logic to show you the configuration of the speed cross-check. You get there by using the drop-down menu of the logic editor. The field MOX 0 logic editor only appears here if a drive monitor was selected in a hardware configuration. For every additional drive monitor, there will be a separate mock logic editor. The drop-down menu allows it to switch between the mock logic and the CPU logic at any time. This makes it quite easy to route signals from the mock to the CPU and vice versa. Okay, let's have a look at the mock logic. In the tab function block, there are motion function blocks and converter function blocks. I'm going to begin with the speed cross-check and drag it in the main window. The other function blocks will follow in the next videos. Now I want to connect the signals of the encoder to the speed cross-check. Under inputs in the cluster MOX 0 encoder, you can find the encoder which you have connected in the hardware configuration to the terminals of the MOX 0. I take each encoder and drag it to one of the motion inputs of the speed cross-check. The function block turns yellow because it's connected to valid signals. To reach the configuration menu, you need to double-click on the function block. The first tab, which appears after opening, shows a short overview of the current configuration. At the moment, we see the default configuration of the speed crosscheck. In the next tab, Units, we have to define the unit which is used for calculating the speeds. Please note that the unit must match with the motion type of the encoders. Otherwise, the function block speed crosscheck turns orange and the configuration becomes invalid. Let's pass over to the tab Inputs. Here, it's possible to enable additional inputs for the error handling. These inputs can be used to reset the system if the output monitoring status goes low, because the allowed relative speed difference is exceeded. To reset this kind of error, there are two optional ways. First, with the input reset. This input can be used to realize a manual reset. This means that an error can be reset by rising edge if the speed is 0. Second possibility, with the input inhibit error reaction. It's possible to realize an automatic reset. If there is a high signal at inhibit error reaction, which indicates that the hazardous area is not accessible, then no error will be triggered. Under these circumstances, occurring errors are reset automatically when the encoder signals match each other. Okay, let's go on to the next tab, Speed Crosscheck Mode. In this tab, we can determine how the speed difference is calculated. We can choose if the speed difference is calculated with sign or without sign. This mainly depends on the application. Furthermore, we have here the option to disable the speed crosscheck. In the tab Limits for Speed Crosscheck, it's possible to determine up to which level a speed difference is tolerated. For this purpose, the permanent limits, absolute tolerance limit for speed difference and limit 1 relative speed difference are set. Furthermore, it's possible to enable two additional inputs, enable limit 2 and enable limit 3. If these inputs are used and a high signal is present at the inputs enable limit 2 and enable limit 3, then the exceeding of the value of limit 1 relative speed difference is allowed in the amount of the configured values for the relative speed difference. In this context, the relative speed difference of limit 2 must always be equal or greater than the relative speed difference of limit 1. The same applies for limit 3 with respect to limit 2. Additionally, to each optional limit, there's the option max time limit 2, respectively max time limit 3, with which the limits can be temporarily restricted. Next, we go further to the tab Compensation for Signal Propagation Delay. If one of the two speed signals is transmitted with a delay, for example because of internal evaluation from one encoder, you can check the option Enable Signal Propagation Delay and connect this delayed signal to the motion 2 input. Then, according to the time you enter in the field Signal Propagation Delay of motion 2, the speed values on motion 1 input are delayed during the calculation of the speed difference. In this way, speed differences can be reduced that would otherwise occur due to delayed transmission, particularly on fast changes in speed. Furthermore, you can choose Add Speed Crosscheck on Value Alternation when the speed difference is evaluated. So we can select if the evaluation of the speed crosscheck is carried out continuously by selecting the option Continuous Speed Crosscheck, or we can select the option Speed Crosscheck on Value Alternation, and then the evaluation only takes place if the value of motion 2 changes. If the second option is selected, you need to define the max check pause. Here you set after what time the evaluation has to be carried out if there was no value alternation. This time is necessary to discover potential encoder errors, like for example a cable break. Next, we switch to the tab Speed Output Mode. Here it's possible to determine what value should be output at the motion output. In this context you can choose between the values speed of motion 1, greatest speed from motion 1 or motion 2, and mean speed of motion 1 or motion 2. After that, there's the tab IO command. In this tab we can simply give the function block as well as every in and output a new name which then appears in a logic. Last but not least, there's the tab report. This tab shows a summary of the configured parameters. By clicking on the OK button, the configuration is saved and the menu closes. That's it so far for the tutorial about the function block speed crosscheck. I've explained how to connect the encoder signals to the function block speed crosscheck and how to configure the block. If you need further information, you can take a look at the online help or the operating instructions which you find on sick.com/drivemonitor. In the next video I will talk about the function block speed monitor, where you will learn how to combine it with the function block speed crosscheck and how to configure it.